maybe we can solve an easier one, so that you will be familiarized with the notations if ever you will not be reading the whole book. So I'll just try 5.40 maybe, because there's a word of STP. So calculate its volume in liters of 88.4 grams of carbon dioxide at STP. So we were given 88.4 grams of carbon dioxide. So maybe we write it down. Where about you have 88? What's that, 88? That is usually a mass, is it? 88.4. So that is a mass. 88.4 grams of carbon dioxide, and then at STP, and then find the volume in liters. So at STP, and then your problem is you find your volume in liters. So that's a question mark, and that should be in liters. So solution. So this would be, actually the culprit here is just the STP. So that is a standard temperature and pressure. Standard temperature is 0 degrees Celsius, as I've said. You should read it from the book. And then your standard pressure would be equal to 1 atm. So basically you have how many given? You have pressure, temperature, and mass. So I think again this is a problem of ideal gas. So let's plug our ideal gas law. That would be a PV is equal to nRT. So just like the last problem that we solved, basically we can split up the number of moles, and that would be mass over your molar mass. Okay, how about, sir, for the molar mass? Basically the gas was given, that would be a carbon dioxide, and we have already through with calculating the molar mass of carbon dioxide. As a review, so that would be carbon is 12.011. Again, that is taken from your periodic table, and then that's only one, and then you have two oxygen atoms, so that would be 2 times 15.999. That will give us our molar mass to be 12.011 plus 2 times 15.999, and that would give us 44.009. 44.009 unit would be gram per mole. So basically, what are we trying to solve is the volume. So as you can see from the equation, we can derive our volume to be a mass RT all over volume, and then the molar mass. Okay, molar mass. So that's a simple algebra again. That's your problem, not mine. So we can substitute 88.4 grams, and then the gas constant, of course, we should be listing that in your constants. That would be a 0.082056 unit would be liter atm per mole. And then Kelvin, how about for the temperature? That would be a 0, so 0 degrees Celsius plus 273, that is automatically 273 Kelvin. Okay, and then how about so this would be the pressure, because we're calculating the volume. So pressure is 2 atm, and finally our molar mass is 44.009. Unit would be gram per mole. You look at the units. You have atm here, and then you have atm there, cancel off. And then how about you have mole, number of moles, cancel off. You have grams at the lower side, cancel off. And you have Kelvin and Kelvin, cancel off. So what remains as a unit would be the liters, wherein that must be our answer, because the volume must be in liters. So this one is also an easy peasy. Okay, we take our calculator, 88.4 multiplied by 0.082056 multiplied by 273, and then all over 2 times 44.009, and it will give us, voila, 22.5 in 3 significant figures. How many significant figures do we have? Actually, this pressure to atm might be an exact one, so it's not included in the significant figures. Maybe I could answer this in three significant figures because of the 88.4 grams. Okay, that is in three significant figures and that is the smallest one. So basically, I would answer this in three significant figures. So the answer must be 22.5 unit would be liters. I hope I didn't commit any wrong. If ever I did, then I'll just have to delete it. Okay? Thank you guys for listening. 5 minutes. Okay, not a problem probably.